Good morning, guys. I want to talk to you today about the last thing in the solutions chapter, which is called colligative properties. So it's actually a word that you don't need to know for the regions, but you do need to know the idea of physical properties that change when a solute is added. So again, what it is it is physical properties that change when a solute is added to water. So again, it's a great idea to just write down what I'm telling you and what I wrote down just to help with your learning in this. So the other thing is the more solute dissolved, the greater the effect. So again, physical properties that change when a solute is added to water, and the more solute dissolved, the greater the effect. The three physical properties that we're going to look at are vapor pressure, which we will review, boiling point, and then freezing point. So colligative properties are really important when it comes to like adding salt to boiling water when cooking pasta. So really what salt does is it actually raises the boiling point. So the pasta, once it gets in there, cooks faster and won't be as sticky. The other thing that's important is when they put salt on the roads, the whole idea of putting salt on the roads when it's snowy and icy is that it lowers the freezing point, and therefore the ice turns to water at a lower temperature so that the roads are safer to drive on. So colligative properties are really important to us. Anyway, I want to show you two systems, which is also in your notes, a little bit better pictures in your notes. We have pure water over here on the left side, and then on this side I have a solute dissolved in water. So the way the solute affects it is it's purely from like a physical perspective. So you can imagine this. So if you recall, vapor pressure is the pressure above a vapor in a closed container. Sorry, the pressure above a liquid in a closed container. So if these little water dots represent the vapor pressure or how many particles are in the vapor state, on this side, on the right side, you can see that there's less. And the reason that is only because the solute gets in the way. So the solute gets in the way of a water going from a liquid to a gas. So when you add solute to water, it actually lowers the vapor pressure. So when you add anything to water, it will lower the vapor pressure. Okay, so if you look at this side, because the vapor pressure is lower, it's going to take more energy to get these particles, water particles, from the liquid phase into a gas phase. So the boiling point when you add solute is going to increase because it takes more energy because the solute particles are getting in the way of a water to go from a liquid to a gas. Okay, the same idea with freezing is that it actually is harder to freeze. So that's like when you put salt on roads. It's harder for the water to crystallize because the solute particles are getting in the way. So when you add something to water, it will lower the freezing point. So the takeaways are vapor pressure lowers and freezing point lowers and boiling point raises. Another way to look at this, so that's kind of like the background. Another way to look at this is a thermometer. So if you look at a thermometer, the normal freezing point of water is, that's right, 0 degrees C. And the normal boiling point is 100 degrees C. So this is for normal water, right? Just distilled, pure water. Okay, if you add anything to water and it dissolves, what it's going to do, let me just try to get a nicer color here, is it's going to raise, that's not too good, but the boiling point and lower the freezing point. So you can imagine when you dissolve something in water, it stretches out the thermometer. So let's just say now it's going to boil at 110 degrees C and it's going to freeze at minus 10 degrees C. So again, the conclusion is whenever you add a solute to water, you raise the boiling point. So I'm just going to put an arrow up, boiling point, and then you lower the freezing point, no matter what. The more concentrated, the greater the effect. So I just want to show you one more page, and then we will move on. This is actually from your homework packet, so you might want to grab out your homework packet right now and you can follow along with me. So what I'm going to do is I'm going to switch gears and I'm going to talk about writing equations and how these compounds break up in water, because that's also important. So if a compound breaks up into 2 things versus 3 things, the substance that breaks up into three things is going to have a greater effect on the physical properties because you have more stuff dissolved. So HCl AQ will break up into H plus and Cl minus. So that's two items, two ions really. CaSO4 is going to break up into Ca. And then because SO4 is a polyatomic ion, it's going to stay together and break up. So actually this one would also break up into two. So if I had a 1 molar solution of number 1 and a 1 molar solution of number 2, they would have the exact same effect on boiling and freezing point reduction and vapor pressure reduction. Okay, so would 3, so would 4, so would 5. Okay, let's go to 6. So 6 is barium chloride. So when barium chloride breaks up, it breaks up into the barium ion, which is in group 2, and then it breaks up into 2 chloride ions. So this actually breaks up into 3 components. Now you don't have to be an expert in this. I just kind of wanted to point this out to you that even though things might break up in water, some may have a greater effect than others. And then lastly, if you have something like sugar, I mean, it looks like it will break up into a lot, but because it's covalent, it actually doesn't break up at all. So this would be considered just one particle. So if I was dissolving, say, NaCl in water, NaCl breaks up into Na and Cl, so you basically have a 2-for-1 deal there, so it will have a greater effect. So you want more solute, less water for the greatest effect. If you want the least effect, you have a least amount of solute and more water. So hopefully that will help you in your homework. And again, we will chat today. And if you have any questions and you can't make it, just email me.